Find the distance between the point 1, 1, 1 and the plane 2x minus y plus 5z equals 11. Now, there's a chance that this point actually lies on this plane, in which case if I plug x in for x, y in for y, and z in for z, I should get a true statement. 2 minus 1 plus 5, well, that's not 11, that's the number 6, so I am in the case where this point does not lie on this plane. But it was worth checking. It's not hard arithmetic, and now I know the answer is not 0. All right, well, I know how to calculate this distance. That distance should be the absolute value of the dot product of p times ps and n over the magnitude of the vector n. All right, well, that's my point that I'm going to call S, the point that's not on the plane. I need a point that actually lies on my plane, and I need a vector n perpendicular to my plane, and I know that vector just looking at this equation. That's the vector 2 minus 1, 5. So now we need to generate a point that lies on that plane. Pause the video here and see if you can think of a way to use that equation to find a to find a point that lies on that plane. Okay, so now our job is to find a point that lies on that plane. And if you were thinking about equations in two variables, 2x minus y equals 11, to find a y, you just plug in a value for x. In fact, you could plug in 0 and get an intercept. And that's the same thinking I want to do. I can find an intercept, right? I can find where this graph crosses the x, y, or z axis. If I want the spot where the graph crosses the y axis, I just need to plug in 0 and 0 for x and z, because on the y axis, both x and z are 0. So that's what I want to do here. I'm going to plug in x equals 0 and z equals 0. So minus y is equal to 11, y is equal to minus 11. The point P I'm going to use is 0, minus 11, 0. And there is nothing special about that point. If you plug two numbers in for any pair of these variables and then you can solve for the third one, then you found a point that lies on that plane. And so frequently I'm asked, where did that come from? Well, I just made up numbers and plugged them in, just like I would if I was dealing with a function with one input and one output, instead of a function with three variables. All right, so now I need to find the vector PS. Here's P, here's S. 1 minus 0 is 1. 1 minus 11 is 12. 1 minus 0 is 1. I found my vector. Now I need to do a dot product, and then I'll need to know the magnitude of this vector. PS dot n. 2 plus minus 12 plus 5. So let's see, that is minus 10 plus 5 is minus 5. Now I just need to know the magnitude of n. Well, the magnitude of n is 4 plus 1 plus 25 is root 30. So the distance d I'm looking for is the absolute value of minus 5 over root 30. Or 5 over root 30.